atmosphere and pollution. Today we're going to be talking about different forms of pollutants within our atmosphere and the kind of issues they can cause. Our first slide here is carbon monoxide, CO. And you're going to see a trend here with all these different pollutants, as I'll bring up in a moment. There are various sources of the pollutants, but a majority of them come from transportation, as you can see right here. And that's primarily cars, trucks, planes to a lesser degree. Lead within the air is another example. Now, the biggest source of lead is leaded aviation gas. They've outlawed leaded gasoline about 35 years ago. It reduced knocking in engines. However, planes still do use leaded aviation fuel.
Another source of pollution in the air actually is lead. This used to be in gasoline within cars to reduce knocking of the engine. However, they outlawed that about 25 years ago, and all fuel is now unleaded. However, it is still leaded within aviation fuel, which does the pollution throughout the air now.
Nitrogen oxide. This is the primary source of acid rain, which we'll talk about in a little bit. And again, there are many sources of it, but the majority of it comes from road transportation, automobiles.
Nitrogen oxide. This is a pollutant also from burning of fuel. 40% of it comes from that. Other areas it comes from also is agriculture and burning of energy. You're going to see later that this is a pollutant that creates acid rain.
Sulfur dioxide, another source of acid rain. Again, you see the trend here. There are multiple areas, but a majority of it comes from fuel consumption from primarily cars, trucks, planes, and to a lesser degree, burning of coal in power plants.
Sulfur dioxide is another pollutant that comes from fuel combustion. Gasoline, which is made of hydrocarbons, is not absolutely pure. It does have other chemicals within it, making it impure, such as sulfur. And when this burns, it creates sulfur dioxide, the other source of acid rain.
Now, particulate matter. Particulate matter is basically road dust. And what's interesting is this was not a problem 120 years ago, before we had roadways with cars going up and down. In fact, road dust doesn't get usually more than 20 feet in the air, but we stand at 0.0, so it does affect us. There are other sources of it again. See, primarily most of it comes from road dust from cars right here.
Particulate matter, road dust. This is the largest component that causes asthma as an allergy. Usually it doesn't go more 6 to 10 feet in the air, but that is where we live. And this is primarily caused by cars zooming by, believe it or not.
Methane emissions. This is an interesting one. Methane comes from the decomposition of matter. Our biggest chunk comes from natural gas and burning of it right here. Enteric fermentation. This is interesting. This is basically from stomach acid from cows, basically cows belching. Now, you can say, how can a cow do that? Well, if you think about in Wisconsin alone, there's 6 million people, there's 8 million cows at any one time. 8 million cows doing that much burping, and then there's multiple states that have that many cows. So you can see this actually affects our methane emissions, which, if you remember from the previous class, is actually a greenhouse gas as well. And right along with enteric fermentation is manure management from the creation primarily from cattle as well as swine. Landfills also create fermentation from methane as it decomposes matter underneath.
Methane is a source of decomposition for all living things that die and rot. Plants, animals, everything that decomposes will create methane. However, there are other sources of it, notably from fermentation. Natural gas and petroleum is another source of it. Landfills decomposing, which you'll see in the next slide, and manure management. There are that many cows within the United States that actually does create methane. The average cow you learn in our class creates 30 pounds of poop a day. In Wisconsin alone, there are 8 million cows. So you multiply 8 million cows times 30 pounds a day. That's a lot of poop and a lot of methane, which actually is not the only state doing that, but causes methane pollution worldwide. It's also a greenhouse gas.
Now, we have in the last 25 years began harvesting the methane because methane, as I said, comes from decomposition of formerly living matter. And you see these pipes at landfills. In fact, you go by the Cobb County landfill about a few miles from Lincoln Tech, you will see these pipes sticking up about every 5 feet from the ground. It's collecting methane. And methane is part of the landfill gas. The other part is carbon dioxide. They remove the carbon dioxide.
Methane is also a source of energy. Natural gas consists partially of methane. In fact, these landfills here are now harvesting the methane from underground and converting it into natural gas. Fairly new source of energy.
And that creates a better and cheaper form of natural gas. Now, chlorofluorocarbons are in sprays. They were outlawed about 25 years ago from paint cans, from hairspray. The chlorofluorocarbons, what they do is they actually increase the volume of liquid you could put within a spray can. Let's say a spray can now is under pressure, could hold 8 ounces of a fluid. Chlorofluorocarbons made it liquefied, so you can put 24 ounces within the same amount. Unfortunately, what this caused was, you'll see here,
Chlorofluorocarbons, CFCs. These are outlawed in the United States, but other parts of the world are still using them. This is what they use to refrigerate hairspray, paint, spray paint specifically, anything you can aerosolize, and by making it cold, you can put more within there. Unfortunately, this was causing the ozone layer, which protects us from radiation, become thinner and thinner, and increasing cancer rates throughout the world.
The destruction of our ozone layer. This is over the Antarctic. The blue hole is where there is no ozone. We have ozone about 40, 50 miles up. This protects us from radiation along with our magnetic belts. And there's an increase in cancer rates, skin cancer rates, as the chlorofluorocarbons went into the atmosphere and then destroyed the ozone layer. So several countries, including the United States, have outlawed chlorofluorocarbons, but it's not completely outlawed.
Here's pictures of the ozone layer at the South Pole, where you see the blue where the hole is. You can see it's gotten bigger and bigger over the years. However, it has started covering back up. You see by 2012, it is starting to diminish. And that's as more and more countries get rid of chlorofluorocarbons for aerosols.
Additionally, other areas...
Dioxins and PCBs. PCBs stands for polycarbonate
very similar,
biphenyls.
actually. Dioxins come from the
Dioxins PCBs have chlorine within them.
Paper we have is
very
white.
poisonous.
Well, if you
Dioxins byproduct of bleaching of paper. When you have wood pulp, it's kind of brown.
But
they use
it's
bleach
darker, and we
to make
put
it whiter
bleach
and whiter and whiter.
The more bleach put in, the lighter it gets.
However,
that
byproduct of bleaching that wood is called
highly carcinogenic.
dioxins.
And
Extremely carcinogenic. Same as PCBs, polychlorinated biphenyls. These are in the drums you see electric lines. Fewer and fewer cities have these, but they still do exist. Also highly carcinogenic.
Electric lines, highly carcinogenic as well. They've tried replacing them, but as we said before, that doesn't happen overnight. Biological pollutants such as molds and dust mites. Part of the reason we have increased problems with molds is we've got better architecture. We have less drafty homes. We can live in a subtropical environment year-round. It might get 20 degrees below zero outside, yet inside we can keep it at a balmy 74 degrees. Well, 50, 60, 70 years ago when we had homes that were drafty, the mold couldn't live year-round. Now it does. Same as dust mites. dust mites actually eat the dust that the skin that falls off of us. There are droppings what we're actually allergic to. Now, they would die out in cooler months, but again, we'd have better architecture, so there's less drafts. It's warmer year round, so we got more dust mites and more dust mite droppings.
Biological pollutants, such as molds, roach droppings, and dust mites. The reason molds have gotten larger and larger is as our insulation got better and better, it doesn't get drafty within homes, so molds can live in there year round now. Dust mites, and unfortunately, people are allergic when they're allergic to dust. It's not the dust mites are allergic to; they're allergic to dust mite poop. And unfortunately, dust mites are with us. They eat dead human skin that falls off of us. They are a scavenger, a necessary scavenger, a decomposer within our world.
Now, contrary to what you see in pictures of smokestacks belching up large amounts of smoke, the majority of our pollution, air pollution, comes from vehicles, as we shown earlier.
A majority of air pollution, as I said earlier, is from vehicles, primarily cars, but also planes, trucks, as well as trains. Only 11% is from industry, and only 30% is from buildings. And when I say buildings, that is buildings such as restaurants, offices, where they use energy from the energy plants to keep them warm, keep the electricity going, to keep the AC and the heat going.
In the United States, in 1997, they passed a federal law saying all new cars from 1997 on have to have a catalytic converter. This is about $800 piece of equipment. It's just a steel shell on the outside, but what makes it so expensive on the inside are these platinum cells. When hydrocarbons and carbon monoxide and nitrogen oxide go through these platinum cells, it changes the molecular components and becomes nitrogen, water, and carbon dioxide. And when we get our emissions tests every year in Georgia, this is what they're checking for, basically. And this has reduced pollution in the United States.
Catalytic converter. Catalytic converter is about $1,000. This is a metal casing. It's probably $20. The inside is made of platinum. That's why it's so expensive. That platinum is created to be a series of filters, and what goes inside through it from the exhaust is hydrocarbons, carbon monoxide, and nitrogen oxide, as we talked about, were pollutants. Once they go through the platinum, what comes out is nitrogen, water, carbon dioxide.
Now, short-term effects of air pollution, primarily fine particulate matter, can cause, shortness of breath, chest, difficulty breathing. But really what it affects more are people who are already sick, and it makes them worse, such as with asthma, COPD, which is chronic obstructive pulmonary disease, emphysema basically, as well as other cardiovascular and heart diseases.
Air pollution, the short-term effects, shortness of breath, chest pain, fatigue, that can affect all of us. However, the long-term effects affect people who already have pre-existing health conditions, such as cardiovascular and heart disease, asthma, and COPD, which is chronic obstructive pulmonary disease. The most common form is emphysema. This makes it worse for them.
As I said here, people end up going to the doctor, going to the emergency room, for air pollution problems. The problem is those, like I said before in the previous slide, when you have an issue already, it exasperates it. So it does increase the death rate in ER visits, which increases our medical costs nationwide.
You see where air pollution does cause death at the top of this pyramid. And this pyramid, there's fewer and fewer people being affected by it. But at the bottom, what you got to look at is the lung function decrease, inflammation, cardiac effects. This is increased health costs for everyone.
Interestingly enough, deaths related to outdoor air pollution, as I've said in the last couple of slides, You would think it'd be cancer. That's why I would think it'd be like lung cancer. No, but primarily it's from increase in stroke and heart disease, and to a lesser extent COPD. People already have these problems will be exasperated by polluted areas.
What's interesting is that from air pollution, you look at this graph here, a majority of air pollution does not cause lung cancer. As I said before, it exacerbates other problems: lower respiratory infections in children, COPD, stroke, and heart disease. People are already sick, get greatly affected by air pollution. This is a summation of air pollution by the chemicals as well as the long-term effects we've discussed previously.
Now, one of the newest pollutants we've seen, and it's not new, but new we realize again with strong architecture we've had, is radon. Radon is a colorless, tasteless gas that occurs naturally in the soil. Now, when we had draft your homes, it would just go through the home. But now with better architecture, it stays trapped using lower levels, and this can cause cancer. As again, it's radioactive, it's a gas, it's primarily found in the soil. Now, here in Georgia, especially northern half of Georgia, we don't have much of a radon problem because we have clay soil. Clay is notoriously good at absorbing radiation. However, if you are concerned, you go to Home Depot and they have radon detectors, usually about $60, $70, or Lowe's as well.
Radon is a naturally occurring radioactive material. It's a gas that occurs in our soil. And as I said before, with increased insulation and the addition of basements, this radon gas, which naturally seeped through the house until the last 40, 50 years, now accumulates and can cause cancer long term. Not a real problem here in Georgia where we have clay in the soil. This absorbs radon, but it does occur in many other parts of the country. And you can actually get a radon tester at your local Home Depot or Lowe's for about $100.
I mentioned earlier about acid rain, primarily coming from nitrogen oxide and sulfur dioxide. And I've got a couple of buildings here spewing out smoke, but it really is primarily from automobiles. And the interesting thing is, it changes the water slightly. It wouldn't hurt you, the acid rain. But it's acidic enough over a period of several years, it does destroy the chlorophyll within the plants.
This shows the pathway how acid rain is created from sulfur dioxide as well as nitrogen oxide from factories. It gets within the atmosphere, gets absorbed within rainfall, and falls on forests later, usually no more than 50 miles away.
On the right here is a branch from a pine tree without acid rain. On the left here is acid rain over 2 years, and you can see it. The needles are yellowing, so it does have a greater effect long term on the chlorophyll.
This is an example of the acid rain effect on the branch on the left compared to no acid rain on the right. And this is not over one rain, this is after over 2 or 3 years. But it reduces the chlorophyll intake, ultimately killing the plant.
Finally, reducing air pollution can be done with recycling, because now we're no longer mining. Aluminum, 92% recycled, can really reduce it, 90% copper, plastics, even paper. We're not mining it or harvesting it and transporting it across country, nor are we using factories to melt it and burn it and modify it. It's already been made. We just need to recycle it with some lesser use of energy.
Recycling will reduce factory work. And by reducing factory work, because you're using materials that have already been harvested, you reduce air pollution.